Grace, and I'm currently an associate professor of mechanical engineering at UC Berkeley, and really excited to talk with you today. It is such an honor to receive this award. Receiving the 2025 Advanced Young Innovator Award is both deeply humbling and also very motivating. On a personal level, it feels like kind of just taking a moment of gratitude to reflect on the journey and the people who have supported me throughout it all. This includes my family and friends, mentors, collaborators, sponsors, and also my research group. I'm just really grateful for everyone that has joined me on this journey. Professionally, this award is especially meaningful because it recognizes our work that bridges fundamental understanding and real world impact. My group's research sits sort of at this intersection of materials, bioinspiration, computation, and also machine learning. And this honor reinforces the idea that kind of integrating these perspectives can accelerate discovery and enable new technologies. I also see this award as an opportunity to build collaborative research environments, to mentor and empower young researchers, and to contribute to shaping how our field grows and evolves over time. Traditionally, materials development relies on typically these slow trial and error processes that can limit efficiency and oftentimes lead to higher production costs and suboptimal use of resources. And so something in my group that we think about a lot is, what if we can reimagine this process by learning from nature, while also incorporating state-of-the-art artificial intelligence and advanced computational tools to help to speed up materials discovery. Now, nature is a powerful inspiration here because biological systems, they operate and manufacture under severe constraints. So with limited resources, limited materials, limited energy, and yet they're still able to evolve these remarkably efficient and sophisticated architectures. And so one example actually comes from our work inspired by owl feathers and cicada insect wings. Owls achieve almost near silent flight, and cicadas operate efficiently across these complex flow environments. And so we translated these biological strategies to solve a very challenging engineering problem. And that is to design drone propellers that are both quiet and also very efficient, which are often properties that are competing for drone propellers. And so with this hybrid design from nature, specifically owls and cicada insects, we're able to achieve reduced noise of around 5 decibels and also increase efficiency by 20% compared to a state-of-the-art industry benchmark. And what's actually really exciting is actually what we're working on right now. We are using computation, optimization, and AI to generate high performance designs that are not directly learning from natural systems, but emerge from these advanced tools like AI. And so we actually then turn this process around. We map these optimized designs back to biology and ask which organisms exhibit similar structures and what environmental pressures may have driven those types of solutions. And so doing so, bioinspiration is kind of used as also like a discovery tool. And at the same time, we're deeply interested in how environment, process, structure, and properties are fundamentally connected. Now, in manufacturing, the environment is in which a material is made. And so this can include the temperature, the humidity, vibration, or even gravity can influence how a structure forms and also how it performs. In many ways, this mirrors biology. The environment an organism lives in can shape how it evolves, favoring certain structures and functions over others. And so by bringing together these elements, we aim to kind of reshape the way we develop and discover new materials. My perspective is deeply rooted in my family. Growing up, I watched my parents work tirelessly to build a better future for us. And I learned early on that meaningful progress is often invisible at first. So built quietly through daily effort, patience, and also sacrifice. Years later, during periods of slow and uncertain progress in our research, that memory kind of came back to me. And it was mentors and colleagues that helped me recognize that unseen effort and small changes in progress were essential steps in building something whose value only becomes clear over time. And so when we have these like invisible outcomes, they're oftentimes like the most difficult moments that we feel. And actually, it's a time that we most want to give up. And so their support is what really kept me going. And this has shaped not only how I approach research, but also how I support and mentor others. And so today, I'm constantly inspired by my students and postdocs. Watching them grow, overcome challenges, and succeed is incredibly motivating. And their curiosity and excitement for discovery continually to renew my own motivation and reinforce the idea that innovation is at its core a shared journey. So one message I often return to, or this quote that I often return to, actually comes from a Korean drama that I actually watched in the past. And the quote is, "Sometimes the wrong train takes you to the right station." And I think that idea is especially important for young scientists because research paths are rarely linear. Experiments fail, ideas change, and projects evolve in unexpected directions. And so, what it may initially feel like a setback or a detour, can ultimately open doors to entirely new insights. And so I would encourage young scientists, engineers to embrace those moments rather than avoiding them. Be bold in asking questions that don't seem to have clear answers, and don't be discouraged if the path forward looks uncertain. I think strong fundamentals and perseverance provide the foundation, but creativity often emerges through exploration and redirection. So much like in optimization algorithms, the best outcomes comes from balancing exploration and also refinement. So, and I think this principle applies just as well to research as it does to life. And so just staying curious, being open to collaboration, and willing to take reasonable risk. I feel like even the wrong turn can lead you exactly where you need to be.